Hello, it's Keith here, and this is lesson 30 of the simple series of my Z80 assembly programming tutorials. We're back on the Spectrum Next today, and we're back on the subject of drawing sprites. We've had in the past a sprite we can move around the screen. However, now we've modified the routine so that the sprite can go partially off the screen. We've got a clipping routine going on here. This is the same sprite clipping routine that I've been doing on a variety of other Z80 and other systems as well. And we're going to be looking at the Spectrum Next version today. Now we're going to split this into two parts. The first is the clipping routine and the sprite drawing, and then the second is the optimizations. We're using double buffering, and we're also using stack misuse to speed things up. So that's what we're looking at today. Now the first thing I do want to point out though is that although this doesn't look so great, we're actually in the 256 color mode today. The graphics are just 4 colors, so that's why we've only got 4 showing. The other thing is the Chibiko is slightly inverted, and that's because I've set the colors so that the screen area is colored in purple, and that has inverted the character. But we're using an XOR sprite routine today because that was what the original example used, but you could turn that off if you don't want that. Now, first of all, what we need to do in these tutorials is discuss the theory. The first thing we're going to need to discuss is how we're actually calculating our coordinates. Now, in these tutorials, we have a bit of a challenge. The Spectrum Next screen is 256 by 192, very nice screen resolution, very good, and that will work very nicely within an 8-bit byte, because of course 0 to 255 in an 8-bit byte. However, the problem is, if we're going to have our sprites partially off the screen, we need to have coordinates that are outside of the visible screen range. And so what I've done is I've used a logical coordinate system where one logical unit is 2 physical pixels. And so our 256 by 192 screen becomes a 128 by 96 logical unit screen, and we can then center that within the 0 to 255 range on the X and Y axis, and that allows us to have reasonably large sprites entirely outside of the visible area, and then they can come into the visible area as required. And so in the example of this Chibiko bitmap here, if the top left corner was over here, well, part of that is outside of the visible area, the dark area here, and part of it is visible, the light area there. And then what we're going to need to do is we're going to need to crop that sprite accordingly, and that's what we're going to discuss next. We need to have an algorithm to allow us to remove the parts that we don't want to show. So let's go over to the blackboard and let's discuss that. Okay, so here's our blackboard. So basically what we've got is we've got our screen. There is our screen, that's what it's going to look like today. And then we've got a sprite. There is our sprite. There it is. And our sprite is going to move around the screen. So our sprite moves around the screen, and while it's all entirely on the screen, there's not much to do. But when our sprite goes off the screen, we're going to need to start doing things, and there's going to be a couple of things we're going to need to do. Now, we're using the bitmap routine that we used before, so we're passing it a bitmap data file, a bitmap data in memory. We're passing it a coordinate and a width and a height. So the first thing we're going to need to do is we're going to need to change the height in this case to this amount here. We're going to change the x-axis position, so we're going to start drawing from 0 and however much has been taken off. But then we're going to need to skip part of the bitmap data because we don't want to transfer that part to the screen at all, of course. Now that's what we do on the top of the screen, but of course if we go off the bottom of the screen, the routine's going to be different. We just want to change the height there, and we don't need to skip anything because we'll just give up before we get to the bottom of the bitmap data. On the left hand side though, it gets a little bit interesting. We're going to change the width, of course. We'd change the X drawing position to here, and then we've got 2 things to do. Now the way my drawing routine works is it goes from left to right, top to bottom in a zigzag pattern. So what we would need to do first is we would need to skip this part of the source bitmap data on the first line, but then on each following line we would need to skip this part here. So there's a couple of things we need to do there. Now on the right hand side we would also need to change the width, of course, and we would need to skip the data after each line, but we wouldn't need to skip anything before the first line. The tricky thing, of course, is that we aren't just relying on it being off one side, it could be off multiple sides at the same time. In the original Chibiakuma's game, couldn't do that correctly. There was a bug in the code. However, hopefully there isn't a bug in today's code, and hopefully today's code works a lot better. Okay, now as I say, there is basically 2 versions of the code. You're getting a bit of a bonus here. There is a version that uses stack misuse, and there is a version that doesn't, and we can just disable the stack misuse by remming that out and running our program again, and hopefully it will still work. So here we go. Now the visual appearance is basically the same. The only difference is that we are now loading in the data a little bit more slowly. And this system doesn't make too much difference, and we'll discuss why in a moment. So let's take a look at the draw sprite routine. Now we're not going to discuss the joystick reading because that's not changed, and the clear screen we're going to discuss next time when we're looking at stack misuse. What we're going to discuss today is the draw sprite routine. Now the first thing we're doing here is we're disabling interrupts, and the reason for that is we are going to be doing things with the ROM area of the memory. We're using layer 2 here, the 256 color mode, and that is accessible through the low memory area. Now, we are loading our source bitmap data into IY here. We're loading the width and the height into H&L. Now, these are 24 by 24 in logical units. And there's 2 pixels per logical unit. So that is 48 by 48 in pixels. It's the same bitmap data as before. We're then running our do crop routine, which does our calculations. And it will set the carry if the sprite is entirely off the screen, in which case we would give up. If the sprite's not entirely off the screen, we run get screen pause. This calculates the VRAM destination. It also pages in the part of the video memory that is the correct part for the first line of the sprite. We then run the show sprite routine, and we'll look at all of that in just a moment. What we're going to look at first is the do crop routine though. Okay, the other thing to bear in mind is that B and C are the X and Y position, again in logical units. Everything is logical units in this tutorial. And to be honest, it makes it a lot easier for multi-platform stuff as well if you're working in logical units, because say some of the systems like the CPC 320 by 240 pixel screen doesn't work so well in 8-bit sometimes. So as I say, working in this logical unit format is very helpful. Okay, well let's look at the do crop routine. Here it is. So when this is run, B and C are the X and Y position, the H and L are the width and the height, and the source bitmap is in IY. So make sure your interrupts are disabled because this Spectrum uses IY for the operating system, I believe. The firmware will use that as well. So there we go. Now, the first thing to bear in mind is D and E are actually used as temporary variables in this routine. Now, at the very start, we're setting up our get next line routine. We're using self-modifying code, and we've got 2 versions of the get next line. Get next line will calculate the next VRAM position and also do any bank switching required. But however, if we are skipping bytes after each line because of some kind of horizontal cropping, then we would need to use a different routine, and we're self-modifying in the routine to use. So we're setting the default one up here at the start, and we will switch in the other one if needed. Now, what we're doing next is we are loading in the Y position from C into the accumulator. Now, if we've got our sprite, if you imagine that this is our sprite, we're looking at our sprite and we're going to consider it and see if it's off the top of the screen. So what we're doing is we're subtracting the minimum Y pixel in logical units of the visible screen. And so this would effectively, if we are in a position like this would result in a positive value, but if we're in a position like this, we would have gone negative at this point. And so if we've not gone negative, then we're going to skip the next section because we would not need to do any top cropping. Otherwise, if we have, we convert that negative to a positive and we compare it to the height. Because if the sprite is entirely off the screen, well, that is going to be more than the entire height of the sprite. And so in that case, we would give up, go to all off screen. Now, all off screen, all it does is it sets the carry and returns, because remember the calling routine was checking the carry and it was going to give up if the carrier was set. So that's why we're doing that. Otherwise, we're storing the amount to remove from the top in E. We're setting the A to 0, and that's because that is the new Y position. Now, that's still in logical units, but it will now be based on 0, based on the top of the screen, and we'll convert it to pixels later on. What we're doing next is we're adding the height of the sprite, and we're subtracting the height of the screen. Now, if this isn't negative, then the sprite must be somewhere off the bottom of the screen. And so what we're doing next is we are going to then compare to the height of the sprite and see again if we're off the entire sprite is off the bottom of the screen, and again we'll give up if it's not. We then store the amount to remove from the bottom in D. So we've got both the amount to remove from the top and the amount to remove from the bottom. We add those two together, and if at this point it's not 0, then there is something to remove, otherwise we can skip over the next section. What we're doing here is we're updating L to be the new height, considering the amount to remove from both the top and the bottom. The next thing we're doing here is we're going to skip any bytes from the top of the sprite, because remember, if you think of our Chibiko character here, if our sprite off the top of the screen, we need to skip some of the source bitmap data before we start drawing, and that's what we're going to do here. So what we're basically doing here is we are taking the width of the sprite in logical units and we're converting that to pixels here, and so we're doubling the width in logical units to get the width in pixels, and then we are doubling the amount of lines to remove in logical units so that we get the actual number of lines to remove in pixels. And then we've got a very crude multiplication routine here where we're basically skipping that number of bytes from the source IY bitmap. And we're just repeating now, that's not a very good multiplication routine, but this will only be run in the rare case when the sprite is off the top of the screen. And generally speaking, most of the time this is not going to be run for most of the frames of your game, shall we say. So it's not going to be a major priority optimizing this kind of routine. Okay, so that's the vertical cropping. We're now going to do basically the same thing for the horizontal cropping. So we're resetting DE, we don't need the old values anymore, and we're now going to do the same with the left-hand X position. So we're now considering and seeing if our sprite is somewhere like this. Okay, so we're taking the X position, subtracting the minimum X logical unit position, and again, if that has not gone negative, then we're not off the left-hand side of the screen. If it is, we convert it back to a positive compared to the width, and if it's more than the width, we give up. Otherwise, we store that in E, and we X the accumulator, which is the X position. We then add the width of the sprite and we compare to the width of the screen, subtracting the width of the screen here. And again, if that's not gone negative, then we're obviously off the right-hand side of the screen. And if that's the case, what we're doing next is we are checking and seeing if that is the entire width of the sprite. And if it's not, then there is something to show. So we're storing the amount to remove from the right-hand side in D. Okay, well, we've now got the two parts. So again, we're adding those two together, and we are then seeing if there is anything to remove here. Now we've shifted that to the left to convert it to pixels and bytes as well, because 1 pixel per byte on this system, and that's because we need to now set the sprite horizontal clip, which is the amount to remove after each line, and that's self-modifying code there. You can see there's +2 -2, and that's because we're modifying a byte within a command within the code. And so that's how I do the calculations. I create a label that explains the calculation that needs to be done to get to the byte that I actually want to change. We'll see it in a moment. And then we are storing that in D here. And what we're doing here is we are basically updating the width of the sprite here. So we are now updating H to be the new width of the sprite with anything removed. Final thing we need to do is we need to remove those pixels from the left. If we're completely off the left, we need to skip something before we start drawing, and that's what we're doing here. We're loading in from E the amount to remove from the left into the accumulator. D and D aren't needed anymore, and so we're now turning on get next line with clip via self-modifying code. We're patching that in here, and we've done it at this stage because, as I say, D and D are no longer needed. And then finally, all we're doing here is we are adding the amount removed from the left to the IY register after converting it to a number of bytes here. Okay, so we're done. So now all we need to do is we need to convert our logical units to final physical pixels. Now there's 1 byte per pixel, and we need to convert logical units to lines. So we're doubling the number of logical units to get pixels, and we're doubling the number of logical units to get lines here. We're then ORing A just to clear the carry. That's all that does, and then we're returning. And that is how we are calculating our cropping and getting the values ready for the drawing routine to work. Okay, so let's just take a quick look at get screen pos again, because we need to understand how our bank switching is working. So basically, the way I'm doing things these days within these tutorials is I'm using the 2000 to 3FFF range to page in an 8K chunk of the 48K screen of the layer 2 screen. And the reason I'm doing that is that leaves the 0 to 1 FFF range, which we can page some memory into and have an interrupt handler at that range, or if we're using the ROM interrupt handlers as well. So this is more flexible than the old way I was doing things, where I was just paging that entire range to a part of the layer 2 screen. So basically what we're doing is we're taking these bits of the Y line, and this is basically the offset within the bank. Now we are then ORing in the bit 5 there. The reason is, as I say, we're going from the 2000 to 3FFF range, and so we are selecting the correct part there. So that is from the Y line, and then what we're doing is we are then taking the remaining 3 bits of the Y line, and this is effectively the bank number. Now the 48K range is being split into 6 8K banks. And so we're taking those 3 bits there and we're shifting them to the low bits here. And then what we're going to do is we are going to effectively send those to next reg 51. Now we are effectively going to use banks 8 or 11 in 16K banks but that is 16 or 22 in 8K banks, and we're using 2 because we're going to use a double buffer. So one buffer is visible while the other buffer is being drawn, and we'll discuss that more next time. We're using register 51, which is paging in one of those 8K banks to the 2000 to 3FFF range. So there we go. A bit of a pain, but as I say, I think this is the best way of working with the layer 2 screen and allowing as much functionality with regards to the interrupt mode 1, because I really don't like interrupt mode 2. I don't like it, so we're not going to use it. Okay. So here is the show sprite routine. So we're transferring the source bitmap data into DE here. At the point that this runs, we've now got the width in IXH, and so what we're going to do is we're basically going to read bitmap data in from DE, XOR it with the screen, VRAM destination and HL, and remember the get screen pos routine has already paged in the correct bank, and we're writing it back. And so this is an XOR routine, and then we're just incrementing the source and destination data, decreasing the C count, the width, and we're going to repeat. And so then once we get to here, we've done an entire line. We're then going to jump to the get next line routine, but we're using self-modifying code here, and we're going to potentially patch in a new routine here. The basic get next line routine, all this does is it will move down a line in the HL destination, and if we've now gone over an entire bank, then what we're basically going to do is we're going to move to the next bank here. That's what this is doing. So we're moving through each of those 8K banks as we move down the screen. It wouldn't work if we were going up the screen. We'd need a different routine to do that. So that's the version if we are doing no horizontal cropping, but if we are horizontal cropping, we need to skip some source bitmap data in DE. And we're doing that with this routine here, and this would be patched in so that this jump would become a jump to get next line with clip. Remember, you saw that in the do crop routine. And this HL loaded with 0 would not actually load with 0. It would be self-modified by this sprite hclip plus 2. The plus 2 is because if we subtract 2 from that, we will get the low byte of that 0 pair that's being loaded into HL. And so that's the number of bytes we want to skip after each line of our source bitmap. So we're adding that to adding DE to HL, but we're ending up with that value in DE here. And that is so that once we have done each line, we are then returning. We're using a jump here, and that's because the other version that uses stack misuse, we can't use calls, so we're using a jump here. Jumps are slightly faster as well. And we're decreasing the Y count here, and we're just repeating until our sprite is drawn to the screen. So there we go. So that's the end of today's example. Now, as I always say, you can go to my website, download the source code, download the build script, and you're quite welcome to use these in any way you want. I don't really think they're good enough that you can make some amazing game from them and earn millions of dollars, but if you somehow do so, good luck to you. You're welcome to use my code in that way. You don't need to give me credit or anything. You're welcome to do it. Anyway, I hope you have some fun with it. I hope you enjoyed the tutorial. If you have, please like and subscribe. Thanks for watching, and goodbye.